Scientists warn we are on the brink of a new ice age. ***. Experts and climate scientists discuss the possibility that Earth may face a new ice age. While this seems paradoxical in the context of global warming, disruptions in the ocean circulation system, particularly the Gulf Stream, could lead to sudden cooling in certain regions. Science 4. Real will highlight these issues in this video, so let's explore further. ***1. Warning of a new ice age. An ice age is a prolonged period of decreasing global temperatures, leading to the expansion of continental ice sheets, polar ice, and mountain glaciers. You might be surprised to learn that we are still in an ice age. From a recent geological history perspective, ice ages are not rare phenomena. Over the past 2.6 million years, the planet has experienced more than 50 ice ages, interspersed with warmer periods. These changes are driven by various factors, including Earth's position in the solar system and CO2 levels in the atmosphere. Ice core samples from Greenland and Antarctica reveal chaotic fluctuations with a cycle of about 1,500 years. These rapid shifts can occur within decades, causing significant temperature changes. One of the most notable examples of such rapid changes is the Younger Dryas cooling event, which occurred about 12,000 years ago. This event saw temperatures in the North Atlantic region plummet by about 5 degrees Celsius in just a decade, and the cold spell lasted for about 1,000 years. In the context of ongoing global warming, it may take a very long time for a new ice age to begin. However, we are currently still in an interglacial period before transitioning to a new ice age, and theoretically, this phase could last up to 10,000 years. Currently, predicting when a new ice age will occur is challenging, as the main causes of ice ages are not fully understood. However, with advancements in science and technology, we will certainly gather more evidence and understanding to help determine the exact timing of a new ice age shortly. Next, we will discuss the crucial role oceans play in regulating global climate by absorbing solar heat, moderating air temperatures, and storing carbon. ***2. The role of oceans in climate regulation. Research aims to understand how oceans interact with other components of Earth's climate system, including land, atmosphere, sea ice, and living organisms. The climate system connects land, atmosphere, oceans, and life on Earth. Oceans cover 70% of the Earth's surface, serving as a primary factor in global weather and climate changes, and facilitating over 90% of global trade while sustaining 40% of life within 100 kilometers of coastlines. The world's oceans function as a massive heat distribution system, moving warm water from the equator toward the poles and cold water from the poles back to the equator. This system, known as the Great Ocean Conveyor or thermohaline circulation, is a key component of global climate regulation. In the North Atlantic, this system manifests as the Gulf Stream, which brings warm water from the Caribbean northward, keeping Western Europe much warmer than it would otherwise be at its latitude. As this warm water reaches higher latitudes, it cools and becomes denser. If it becomes dense enough, it sinks to the ocean depths, forming what is known as North Atlantic Deep Water, NADW. The process of water sinking in the North Atlantic is a crucial driver of the global ocean conveyor. It pulls more warm water northward from the tropics, perpetuating the cycle. However, this system is delicately balanced and susceptible to disruption. The density of seawater depends on both its temperature and salinity. As global temperatures rise, increased melting of Arctic ice and Greenland glaciers is pouring more fresh water into the North Atlantic. This fresh water is less dense than salt water and can form a layer on the ocean surface, preventing the cooled water from sinking. If enough fresh water enters the North Atlantic, it could potentially halt the formation of NADW, disrupting the Gulf Stream and the broader ocean conveyor system. This disruption could lead to rapid cooling in the North Atlantic region, potentially triggering a little ice age or even a full-scale ice age. Oceans are not only part of the ecosystem, but also play an essential role in regulating global climate. Understanding the role of oceans is crucial for developing strategies to respond to climate change and protect the balance of Earth's climate system. Disruptions in ocean systems could have far-reaching impacts on climate, ecology, and the global economy. Next, we will explore how the emergence of extreme cold weather phenomena highlights the complex impacts of global warming. ***3. The paradox of cooling due to global warming. The paradox of cooling due to global warming refers to the phenomenon whereby rising global temperatures, primarily due to human activity, can lead to cooling effects in certain regions, particularly in the Arctic and North Atlantic areas. Increased temperatures cause the melting of ice in the Arctic and Greenland, resulting in fresh water flowing into the oceans, especially the North Atlantic. This fresh water is less dense than salt water, creating a layer of lighter water on the ocean surface. This prevents cold water from sinking, disrupting the thermohaline circulation of which the Gulf Stream is a crucial part. The weakening or even shutting down of the Gulf Stream could lead to lower temperatures in the North Atlantic and surrounding regions like Western Europe. Average temperatures in areas such as the UK and Northwestern Europe could drop by 5 degrees Celsius or more, resulting in colder winters and changes in weather patterns, such as shorter summers and more storms. The paradox of cooling due to global warming serves as a clear illustration of the complexity of Earth's climate system. The interplay between rising temperatures and changes in ocean currents can lead to unexpected consequences, ranging from cooling in some areas to extreme weather events. Moreover, our understanding of these complex systems is still evolving. Recent observations of ocean freshening and weakening currents have occurred faster than many models predicted, suggesting that we may be underestimating the potential for rapid change. Next, establishing reliable scientific evidence and understanding the debates surrounding this issue becomes more important than ever. 4. Current evidence and scientific debate. The scientific community is actively debating the likelihood and potential timing of a new ice age triggered by global warming. Human activities are the main drivers of the significant increase in global temperatures over the past century, with an increase of about 1 degree Celsius compared to pre-industrial times. This is supported by the rising concentration of greenhouse gases in the atmosphere, primarily from fossil fuel combustion. The melting of Arctic and Greenland ice is occurring rapidly, with satellite data showing increasing severity of ice loss in these regions, contributing to rising sea levels. Additionally, ocean temperatures are also rising, causing changes in water circulation systems and the ability to absorb CO2. Studies indicate that oceans have absorbed about 30% of the CO2 released by human activities. Recent satellite observations have shown that salinity in the North Atlantic is decreasing, which could lead to a weakening of the Gulf Stream. This has prompted many discussions and studies on how these changes may impact global climate. Numerous studies have recorded an increase in extreme climate phenomena, such as major storms, floods, and droughts. While weakening ocean circulation could lead to cooling in some areas, this effect competes with the overall warming trend due to greenhouse gas emissions. The net effect in different regions is challenging to predict. There is significant debate about how quickly these changes could occur. Some researchers suggest it could happen within decades, while others argue it may take centuries. Continued research and data collection are necessary to better understand our planet's climate and the impact of human activities on it. Next, we will explore how climate change affects not only the environment, but also has profound implications for the global economy. 5. Global impacts and economic consequences. While the immediate effects of a weakened Gulf Stream will be most pronounced in the North Atlantic region, the potential impacts of such significant climate shifts will be global in scale. Climate change could lead to an increase in global average temperatures, resulting in changes in weather and climate patterns. Regions may experience more extreme weather, including major storms, floods, droughts, and heat waves. These phenomena not only cause direct damage to the environment, but also have profound impacts on the economy, particularly in agriculture, fisheries, and energy sectors. In Europe and North America, we could see significantly colder winters, shorter growing seasons, and more extreme weather events. This could have severe implications for agriculture, energy demand, and infrastructure designed for our current climate. Moreover, changes in climate conditions could reduce agricultural yields. Increased temperatures and variable precipitation could lead to crop failures and diminished product quality. Farmers may face higher costs to adapt their practices and respond to harsh weather conditions, potentially resulting in food shortages, rising food prices, and impacts on global food security. Some regions may experience increased warming, while others might see changes in precipitation patterns, potentially leading to more frequent droughts or floods. Changes in ocean circulation could affect sea level rise, potentially accelerating it in some areas. Ocean circulation plays a crucial role in distributing marine goods, and changes could profoundly impact marine ecosystems and fishing industries. The global impacts of climate change and economic consequences are complex and serious issues. Properly understanding these impacts and implementing appropriate measures are essential to mitigate risks and build a sustainable future for everyone. Timely preparation and action will help minimize negative impacts and take advantage of new opportunities arising from the transition to a sustainable economy. Asterisk. Next, accurately predicting and monitoring climate change is becoming increasingly difficult, posing significant challenges for science and global environmental management. Asterisk. Asterisk, asterisk. 6. Challenges in prediction and monitoring. One of the biggest challenges in understanding and predicting potential rapid climate changes lies in the limitations of current monitoring systems and climate models. Our knowledge of ocean circulation relies heavily on limited data. One major challenge in predicting and monitoring climate change is the lack of accurate and comprehensive data. Many regions of the world lack sufficient climate monitoring stations, which limits the ability to collect information on temperature, humidity, rainfall, and other climatic factors. This data gap can lead to inaccurate predictions about climate trends and difficulties in detecting significant changes. The Earth's climate system is a complex network that includes multiple factors, from oceans and atmosphere to land. Interactions between these factors can lead to unforeseen feedback, making it challenging to predict climate change. This complexity also makes it difficult for current climate models to fully simulate the fluctuations within the climate system. While there have been significant advancements in developing climate models, they still have many limitations. Many models cannot fully reflect natural processes, such as changes in ocean circulation, ecosystem dynamics, and atmospheric feedback. Asterisk next. Human activity has significantly contributed to climate change, affecting the future of the planet and raising questions about our responsibility and actions in protecting the environment. Asterisk. Asterisk, asterisk. 7. The role of human activity and future climate. While natural climate cycles have always existed, the current situation is unique due to the rapid pace of human-induced climate change. The burning of fossil fuels and other human activities have led to a sharp increase in atmospheric concentrations of CO2, methane, CH4, and nitrous oxide, N2O. This increase contributes to the greenhouse effect, raising global temperatures and causing climate change. Land use changes, such as converting forests and natural land into agricultural or urban areas, have also impacted the climate. When forests are cleared, not only is CO2 released, but the capacity of trees to absorb greenhouse gases is also reduced. This increases atmospheric CO2 levels, contributing to global warming. Ocean acidification, another consequence of rising CO2, may affect marine ecosystems in ways that could influence ocean circulation patterns. Understanding the complex interactions between human activities and natural systems is crucial for predicting and potentially mitigating the risks of abrupt climate change. It also emphasizes the need for comprehensive approaches to climate change that consider both mitigating greenhouse gas emissions and adapting to potential rapid changes. This increase can lead to severe consequences, including rising sea levels, increased frequency and intensity of extreme weather events, and negative impacts on ecosystems and economies. Asterisk. Finally, in the face of unpredictable climate changes, preparation and adaptation become vital for ensuring sustainability for both humanity and ecosystems in the future. Asterisk. Asterisk, asterisk. 8. Preparing for an uncertain future. Given the potential for abrupt climate changes and the uncertainties in our current understanding, how should societies prepare? One approach is to focus on enhancing resilience to a range of possible climate scenarios. Investing in new technologies and climate research can help develop innovative solutions to mitigate climate impacts. Renewable energy technologies such as solar, wind, and biomass can help reduce greenhouse gas emissions. Raising community awareness about climate change and related issues is essential for creating positive change. Educational programs can help individuals understand the impacts of climate change and their role in mitigating these effects. On a global scale, improving international cooperation and information sharing is crucial. The impacts of climate change will not respect national borders, and a coordinated response will be necessary to address potential large-scale disruptions to economic systems. We want to hear your thoughts. What do you think about the possibility of a new ice age triggered by global warming? Do you think we are doing enough to monitor and prepare for potential rapid climate changes? Share your opinions in the comments below. Finally, thank you for watching the video! If you found it useful, don't forget to like, share, and hit the bell icon to not miss the interesting videos coming up from Science for Real. See you in the next videos!